Yeah, hello everyone. In this video, we are going to study about the types of chemical reactions. Okay, so if you observe here, he's saying that it was given in this page that we have learnt in class 9 that during a chemical reaction, atoms of one element do not change into those of another element. So it means, suppose we all know that hydrogen and oxygen, okay, hydrogen plus oxygen gives rise to H2O, right? Water. Here, there are two different atoms. Hydrogen atom is different, oxygen is different. And finally, we are getting the product is water. Even though it is changed into water, but it contains hydrogen atoms and oxygen atoms. He's saying that this hydrogen will not change as oxygen. It means hydrogen will not disappear or oxygen will not disappear. They will be present in the final compound also, in the final result also. Okay, but we get a new substance. That is what he's saying. Nor do atoms disappear from the mixture or appear from elsewhere. That is what he's saying. That when hydrogen and oxygen both are gases, and finally after reaction we are getting a liquid here. So though we have a liquid, but atoms will not change. Atoms are there. Hydrogen atom is present and oxygen is present. Okay, that is what he meant to say. Okay, it is not balanced. So if you balance it, you will understand. Now, fine. Now, after that, actually, chemical reactions involves in breaking and making of bonds. So, this example, like hydrogen plus oxygen, okay, hydrogen plus oxygen gives rise to water, H2O. Okay, so this is what he's saying. Oxygen 2, hydrogen 2, then here you keep 4. Okay, no. Now, if you observe here, he's saying that a chemical reaction involved in breaking and making of bonds. Sometimes it will break the bond between the atoms. Sometimes it make the bond. Here, hydrogen is separate, oxygen is separate. So after that, after reaction, they made the bond. So that is what he's saying. Okay, and a new substance is formed that is called water. So you'll study about types of bonds between atoms in chapter 3 and 4. So chapter 3, okay, in metals and non-metals and carbon and compounds that we are going to study, okay, more about the types of bonds between the atoms. Okay, now here there are total four types of reactions. Okay, how many? Total four types of reactions. So this is the first reaction is known as combination reaction. Okay, the first type of chemical reaction is combination reaction. So let us see study what is a combination reaction. So first we should you just note it down in your books. Okay, I'll use the alphabets to make you understand this chemical reaction. Okay, so I'm using here two alphabets. One is A plus B gives rise to AB. Okay, so here in place of AB and in place of these alphabets, I'll take the I'll take the atoms. I'll take the elements. Then so that you will understand. So this is the hint to remember this combination reaction. Or you may write like this also. Suppose if I'm taking three atoms here, A plus B plus C, then the final product will be ABC. So this is called combination reaction. So if I give you the definition of this combination reaction here, so how many alphabets I'm using? Left side, tell me two, right? Okay, two. So suppose if I talk about the definition. So what will be the definition? Tell me here. When okay, when two or more, or okay, two or more substances and two or more substances. Okay, so what are those substances here? I'll use the elements. Okay, two or more in bracket I'll write two or more elements, or sometimes not only elements, even compounds also, or compounds we study. Okay, we will study in the next topic. Combines. So okay, plus A plus B. So A is one element, B is another element, and they I have used the letter. plus it means combine, they are combining. So what happens after combining to form AB? AB is single, right? Previously left side A is separate, B is separate. I have combined them and then I'm getting a single product. Okay, single product. So such type of reactions is called as combination reactions. Okay, such reactions are known as combination reactions. Suppose if you are taking two or more habitants, so in the next example, A plus B plus C, three substances or three elements I took, and finally I got a product. Okay, as I have already explained. So left side we will be having reactants. Okay, these are the reactants. These are reactants, RES, CTA, and TS. And right side, okay, and right side, it is a these are the products. These are products. Okay, understood? Fine. Now, so to make you understand much better, here there are few activities given. Okay, let us see what is the first activity, activity 1.4. So here is saying that take a small amount of calcium oxide or quicklime. It is also called as quicklime. So calcium oxide it's a powder. Okay, it will be in a white color. Okay, in a beaker. He's saying that take calcium oxide powder in a beaker and then slowly add water to this. So he's saying that slowly add water to this. So what happens when we add water and then he's saying that touch the beaker. So if you do this activity, okay, so the calcium oxide, if you add in the water and if you touch, you will feel warm, okay, you will feel it warm. So whenever in any chemical reaction, if heat is released, okay, warmness is nothing but heat is produced, right? Such type of reaction are known as, okay, so such this reaction, okay, you remember uh, formation of slaked lime, okay, such type of reactions are known as exothermic reaction, okay. So what is the exothermic reaction? In any chemical reaction, if heat is liberated or heat is produced in any chemical reaction, those such type of reactions are known as exothermic reaction. So in this reaction, what is happening? Heat is produced, heat is coming out. So this is the example for exothermic reactions. Now what is happening? Now touch the beaker. Do you feel any change in temperature? Yes. You write the answer here. Yes. So what happens? So formation of slaked lime. So slaked lime, okay, in the formation of slaked lime by the reaction of calcium oxide with water. So you'll get a paint. Okay, that slaked lime we apply on the walls. Okay, mostly in villages they we use the paints actually, but in villages they use this slaked lime. Okay, slaked lime is produced when we mix calcium oxide or quicklime to the water. Okay, so let us see the chemical reaction here. Okay, the equation which is written calcium oxide. So what is the formula? CaO, calcium oxide. It is in solid state. Okay, it is a powder. It's a solid, it's like it appears like a stones also. So white color stones. Okay, stone is nothing, not that stone. It is if you break it, it will become into powder. Okay, so quicklime, calcium oxide is also known as quicklime plus water. So when we are adding water here, water will be in liquid state and calcium oxide in solid state. So I have mentioned in the brackets. It is mentioned in the brackets. Then what will you get? So this paste, it's called calcium hydroxide. Okay, so calcium hydroxide, and it is dissolved in water, right? So if it is dissolved in water, we write it aqueous, and it is also known as calcium hydroxide is also known as this calcium hydroxide. Okay, it is given here calcium hydroxide plus heat is produced. So that is the reason it is exothermic reaction. This reaction is which type of reaction? Exothermic. Thermal means heat. Okay, exothermic reaction. So now if you observe here, so what is happening? If you carefully observe, what is we are talking about combination reaction, na? So combination reaction, what is the definition? When two or more elements or products combine to give you a single product. Single product. So here now you observe here calcium and oxygen. It's a compound, right? Okay, compound, and here hydrogen, water. So they are combining each other, and finally we are getting only one substance, one product is called calcium hydroxide. So this is an example of combination reaction. Okay, so it is also given here, underline, calcium oxide and water combine to form a single product. So what is that single product? Calcium hydroxide. So such reaction in which single product is formed when two or more reactants get reacted each other is known as combination reaction. I hope you all have understood. Okay, fine. Now next topic. So yes, this is very important. Do you know? Okay, do you know? And one more point also I'll tell you. So a solution of slaked lime produced in the reaction 1.3 is used for whitewashing walls. Okay. So see what do we get slaked lime? How did we get slaked lime? When we add calcium oxide plus water. Okay. So we get the calcium hydroxide. Okay. We get the calcium hydroxide CaOH 2 calcium hydroxide. So this calcium hydroxide is also known as slaked lime. Okay, slaked lime. It looks like a paint. Okay, a paint because we are adding water here. So slaked lime. And this slaked lime, where do we use? We use for whitewashing. We use as a paint on the walls. Okay, now let us imagine that we have painted it, we have whitewashed it. Then after that, what happened? This calcium hydroxide, after 2 to 3 days, it reacts slowly with carbon dioxide in air. So we have carbon dioxide in the air. So that carbon dioxide will come and react with this calcium hydroxide paint which we are applying on the walls slowly, and it forms a thin layer of, okay, very, very important, thin layer of calcium carbonate. Okay, so thin layer of calcium carbonate on the wall. So what is the formula of calcium carbonate? CaCO3. Calcium carbonate will form the calcium hydroxide when it reacts with carbon dioxide. Okay, very, very important. When it reacts with carbon dioxide in air, it forms calcium carbonate. And this calcium carbonate is formed after 2 to 3 days of whitewashing and gives a shiny finishing to the walls. So it looks very shiny on the walls, okay, after 2 to 3 days. So it is interesting to note that even the chemical formula of marble is also CaCO3. Very, very important. Please do underline. Okay, what is the chemical formula of marble? It is also CaCO3, calcium carbonate and marble. It is having same formula. Okay, so chemical equation is given here. So calcium hydroxide, okay, aqueous because it is dissolved in water, right? And carbon dioxide gas, okay, gas, it gives rise to calcium carbonate, okay, as a white color. It's a layer, okay, it looks like a thin layer and it is in solid state, solid form. So it is mentioned here, yes, and it also gives, like, plus we get the water which is in liquid state because here it is aqueous, right? Hydroxide means oxygen and hydrogen both are present here. Okay, and it also gives the water. Okay, fine. Now let us discuss, he's saying that let us discuss some more examples of combination reaction. So see here, carbon and oxygen gives rise to carbon dioxide. Burning of coal. Okay, so burning of coal, so burning requires oxygen, right? So what is happening? How many atoms are combining here? Our elements are reacting two and giving single product. So this is an example. And formation of water from hydrogen and oxygen I have already explained. So tell me here, hydrogen H2, okay, hydrogen and oxygen gives rise to 2H2O liquid. So two reactants giving one single product. This is also an example of combination reaction. So in simple language, we say that, okay, this is the definition given. When two or more substances, elements or compounds combine to form a single product, such reactions are known as combination reactions. And also we have seen that in activity 1.4, large amount of it is evolved and the mixture has become warm when we have added water in calcium oxide. Okay, so mixture become warm. So in any chemical reaction in which heat is produced or heat is liberated in the formation of products are known as exothermic chemical reactions. Okay, exothermic means giving heat outside, out. Okay. Now, other examples of exothermic reactions. Okay. So, methane CH4 plus oxygen gives rise to carbon dioxide and water. And now it is very, very important. See here, methane gas. Okay, it is a gas state. And here, oxygen gas. Okay. Then carbon dioxide gas. Then here, if you observe water, which state? Gas here. So water is in gaseous state. Okay, this is what you should note down. Okay, and then do you know that even the respiration is also an exothermic process? Yes. So you're saying that even respiration, respire, taking oxygen inside and releasing carbon dioxide, that is also an example of exothermic process. Heat will release. So we all know that energy, we need energy to stay alive. We get this energy from the food we eat during digestion. Okay, so what happened during digestion? Food is broken into simple substances, small substances. For example, rice, potatoes, and bread contain carbohydrates. These carbohydrates are broken down to form glucose, and this glucose combines with oxygen in the cells of our body and provides energy. The special name of this reaction, so whatever this reaction, what is this reaction? When we eat food, when you eat food, that food is getting divided into simple compounds or simple substances, sorry, simple substances, and this entire whole process is called as, this reaction is called as respiration. And the whole process you study in chapter 6. Chapter 6 is from biology, you study in biological science. Okay, and then, so here if you observe, the reaction is given C6H12O6. Very, very important. Okay. Please, you should learn it, practice it many times. Okay. Glucose. Okay. Glucose plus oxygen. Oxygen which is dissolved in the, where it dissolved in the blood. Okay. In the cells, sorry, in the cells of our body. And the glucose which is also dissolved in our body. And then what will happen when you, okay, this is what happens when you take this. Okay. So when you take it, what are you going to release outside? Carbon dioxide and water plus energy. So this is also an exothermic process. Okay. Next, another example, decomposition of vegetable matter into compost. It is also an example of exothermic. Yes. Whenever if your mother have, like, preparing, while preparing the food, after that the kitchen waste which is thrown into the dustbin, garbage, or if you are making any compost with it, so that is also, the decomposition also gives heat energy outside. It is also an example of exothermic reaction. So these are the example that you should remember. Okay. So now he is asking, identify the type of reaction taking place in 1.1 activity. He is asking activity, which type of reaction? You tell me whether it is a exothermic reaction or endothermic reaction. So what is activity 1.1? We have burned the magnesium ribbon, right? Burning of a magnesium ribbon. When you burn a magnesium ribbon, you are using heat energy. So it is exact. Of course, it is also exothermic reaction. Okay. So where should you write this one? You should write in the first page. Okay. I'll go to the first page. So this reaction he's asking. So which type of reaction it is? This reaction is also an example of exothermic reaction. Why? Because in this reaction, heat is produced outside. Heat is liberated. Heat is released. Okay. So that is also another example of exothermic reaction. Next, the next example. Okay. Page number 8. Okay, fine. So decomposition reaction. Okay, what was the first one? Combination. What I have written? A plus B gives rise to AB. Okay, this is a hint to remember. So what is this? What is this hint? Two reactants, two single reactants, or two compounds gives a single compound, or two elements combine and give a single compound. That is an example of combination reaction. Now decomposition reaction. Decompose means divide, right? Reverse of the first one. AB. Okay. This is a hint for you. AB gives rise to A plus B. Reverse of first reaction combination, are, suppose if A, B, C products, okay, A, B is also product. If a product can also be divided into three reactant, three simple substances, A plus B plus C. This is a hint for decomposition reaction. Okay, so this activity already a video has been made, and you may check in the description about this video. So what are we going to do in this like uh, activity? So let us see. Take 2 grams of ferrous. Take 2 grams of ferrous sulfate crystals in a dry boiling tube, and now he's asking, note the color of ferrous sulfate. Okay, what will be the color of ferrous sulfate? The color of the ferrous sulfate, you note down in your textbook, the color of the ferrous sulfate will be in light green color. Okay, green light greenish color. Video already it will be given in the description. Okay, next, after that, after taking ferrous sulfate crystals, so what is he saying? He's saying that, yeah, now after taking it in the test tube, now heat the boiling tube over the flame or a burner or spirit lamp as shown in figure 1.4. Observe the color. Okay, now he's asking, what, observe the color, what will happen? Okay, what type of a color that you will see. Okay, so we did this activity experiment. Okay, so after heating, that light greenish color will get changed into brownish color. Okay, will change into brownish color, and also you'll get the smell, color, and you may write down very, like, strong gas. Okay, that is called pungent smell. Okay, a pungent smell comes out of this chemical reaction. So that is what you should write here. Okay, so brown color, okay, brownish color, and it gives the pungent smell. Now, have you noticed the green color of the ferrous sulfate? Yeah, it's a green color has changed. So what happened? Green color, when you have heated, change into brown. You can also smell the characteristics order of burning sulfur. Okay, so even burning, when you the sulfur, sulfuric acid, right? So it also gives, like, the strong, very strong smell. Okay, so that smell is called pungent. Same smell will come, that strongness also comes from this gas. Okay, when we burn this. Okay, fine. Now the chemical reaction is given. What are we taking? Ferrous sulfate, which is in light green color. So what are we doing? We are heating it in a test tube. So it gives ferric oxide, Fe2O3 solid, plus sulfur dioxide. Okay, no doubt. Sulfur dioxide. It is given already here in this paragraph. Sulfur dioxide. Di means two. Okay, oxygen is two. So that means sulfur dioxide means two oxygen atoms are present. So that is why we use di. And then plus sulfur trioxide. Tri means three. Three. Oxide means oxygen. Three oxygen atoms are present. So this is what comes in the reaction. And ferric oxide is a solid. Ferric oxide, brown color. So it will be in brownish color. And you see the crystals there in the test tube, and they are solid in state. Okay, and also it gives this sulfur dioxide and sulfur trioxide. That is the reason it gives a strong uh, gas. Okay, strong gas. We call it as a pungent smell, which gives a pungent smell in this reaction. So what is happening? See here. Now you remember AB. Okay, AB or ABC gives rise to A plus B plus C. Understood this hint? Now see AB. How many atoms are there? Iron Fe1, sulfur 1, oxygen 1. Total 3. Total 3. It is a compound. After heating, okay, decompose, na, divide. To divide, we are heating. So 1, let us consider this as A, B, C. So when one single product divides into three reactants or three simple compounds or elements, it is known as example of decomposition reaction. So what is the ferrous sulfate formula? FeSO4. Okay, this is not comma, it is dot 7 H2O. This is the formula. So when you burn this, when you do this activity, that light is green, you will find the water droplet, water moisture also forms on the test tube, in the inside, on the surface, on the glass test tube, because it's a crystal which contain water also in it, and it lose that water when you are heating it, and the color changes into brown. It is then decomposed into ferric oxide, sulfur dioxide, and sulfur trioxide. So ferric oxide is a solid, while SO2, SO3, sulfur dioxide and trioxide, sulfur trioxide are the gases. And decomposition of calcium carbonate, okay? Calcium carbonate, decomposition, CaCO3. If you heat this calcium carbonate, it gives calcium oxide and carbon dioxide. On heating, it is also important decomposition reaction used in various industries. So calcium oxide is also called as quicklime. Lime or quicklime, calcium oxide. Already we have learned that in the previous topic. It has many uses. So what are the uses? It is also used in manufacturing of cement. Very, very important. So all this comes under MCQs. So that is the reason why I am explaining each and every line, because in CBSE board exam, question can be framed even from any sentence, okay, any paragraph. So calcium oxide quicklime, where do we use? Many uses. One of the uses manufacturing in cement. Okay, manufacturing cement we use calcium oxide. When a decomposition reaction is carried out by heating, so it is called thermal decomposition. So what is happening when it is carrying out by heating? So it is dividing, right, and giving out the heat energy. So that is why it is called thermal decomposition. So decomposition means division is happening. Dividing, it is division. Dividing is happening only because we are giving the heat energy. So that is why it is called as thermal decomposition. And above the arrow, if you see, we have mentioned the condition also. If you do not use heat, then it won't be divided into, or it don't get decomposed. So that is why it is mandatory. So we write it on the above the arrow. So limestone, okay, it is also called as quicklime. Oh, sorry, it is also called as calcium carbonate. Calcium carbonate, when you heat it, it gives the calcium oxide plus carbon dioxide gas. Okay, so that is the chemical equation which is given. Now another activity 1.6. This activity also, the video has been uploaded, like in the description. Okay, so heating of lead nitrate and emission of nitrogen dioxide. Okay, so let us see the another example. Another activity 1.6. Take 2 grams of, what is he saying? Take 2 grams of lead nitrate lead nitrate powder in a boiling tube. How much? 2 grams. So lead nitrate, okay. And then what is he saying? Take 2 grams of lead nitrate powder in a boiling tube, and after that hold the boiling tube with pair of tongs. So these are called pair of tongs, okay. You will find in the laboratory, and heat it over a flame. What do you observe? So what do we observe? It is we observe that a brown color fume is gas comes out of it. Which color? Brown, okay, given. Note down the change, if any. Okay, so this brown color which comes is lead oxide. Okay, which comes is lead oxide, and also lead oxide, and also it gives the pungent smell. Same, that smell also will be very strong. Okay, of nitrogen. Why? Because it evolves the nitrogen dioxide gas. This nitrogen dioxide gas will be very strong. So, okay, so it also gives the pungent smell in this reaction. This is also example of decomposition reaction. So very, very important. So this question, like this, sorry, this equation, this chemical equation is asked in 2023 for 1 mark in MCQs, set 1 and set 3. Okay, and sometimes he will ask you to write the chemical equation of activity 1.6 also. Okay, what is the activity 1.6? Heating lead nitrate and emission of nitrogen dioxide gas. Okay, so lead nitrate was the formula, PbNO3 NO3 2. On heating, it gives PbO, lead oxide, and gives nitrogen dioxide, and it gives oxygen gas. Okay, very, very important reaction that you should learn it, practice it many times. Okay, now next one, activity 1.7, electrolysis of water. Okay, electrolysis of water. Very, very important. And the same activity, even we have done the experiment and uploaded the same video in the description. So this activity 1.7 we will discuss in the next topic. Okay, fine.